So what will solve equation under capacitor here? Say a parallel plate capacitor has an area of 10 centimeters square. A plate of separation 2 centimeters is charged initially to 100 volts in a vacuum. Calculate, we have 3 questions here. One is capacitance of the capacitor. The other one is calculate the charge of the plates. Well, the last one is calculate the capacitance of the capacitor if the space between the plates is filled with mica wire of relative permittivity 5. So let us pick out the parameter variables given. Here it says the parallel plate capacitor has an area. So the area of the plate is 10 centimeters square. Let's quickly write that out. A is 10 centimeters square. While the two plates they are separated by a distance of 2 centimeters. That is, the distance is given as 2 centimeters. Now, he said it is charged initially to 100 volts. So the potential difference is now given to be 100 volts. So this parameter is 100 volts. Now the first thing is to calculate the capacitance of the capacitor, which is A. The capacitance of the capacitor. We are looking for capital letter C. Capital letter C. Now we know we already have 2 formulas for capacitance of a capacitor. The first one, which is C is equal to Q over V. Can we use that formula? No, because we don't have the charge across the plates. We only have the potential difference across the plates. What about the other formula? C is equal to E naught E arrow A over D. So can we use this formula? Yes, because the area is given, the distance is given. E naught is a constant permittivity of free space, and E arrow, which is the relative permittivity. Now, E arrow will be taken as 1. E naught, which is a constant, is 8.85 times 10 raised to the power minus 12. But before we go ahead to calculate, you will notice that the potential difference at the plate is 100 volts. It is the SI unit. But area is given to the centimeter square, which is not the SI unit. So we have to quickly convert this to the SI unit. To convert centimeter to meter, you divide by 100. But because this is area centimeter square, you have to divide it twice by 100. 10 divided 100 times 100. 1 0 will cancel 0. So we are left with 0.00001 meter square. While this the distance across the two plates is also in centimeter. So to convert it to meter again, we also divide it by 100. 2 over 100, which will give us 0.02 meter. With this, we are good to go. Now, C would that be equals to E naught as we know it is the constant. It's a constant, which is the relative permittivity of a vacuum, which is given as 8.85 times 10 raised to the power minus 12 times the relative permittivity, which is a free space, which is just an empty space, is taken as 1. And area is this, so it's 0.001 over the distance, which is this, 0.02. So we are going to press out the value and get the answer. Okay, let's go to 8.85 times 10 raised to the power minus 12 times 0.001 divides 0.02. It is 4.425 times 10 raised to the power minus 13. Times 10 raised to the power minus 13. Now, what is the unit for capacitance? The unit for capacitance, as you know, is farad.
Okay, now that we have gotten our capacitance, the other question is to calculate the charge of the plates. So in B question, we are looking for charge at either place. So to calculate for charge at either place, we are required to use the other formula for capacitance of a capacitor, which is C is equals to Q over V. Now, this is a follow-up from this question. So we have already gotten our capacitance, and the parameter for both the potential difference across the plate is given. What we just have to do is to make you the subject of the formula. If you do that, we will arrive at Q is equals to CV. So Q is equals to C, which is 4.425 times 10 raised to the power minus 13 times our volts, which is what? 100. So to just take out 2 zeros away, which will now be 4.425 times 10 raised to the power minus 11. And the unit for charge is coulombs, as we know it. Now we want to proceed to the third part of the question, which is the capacitance of the capacitor. So we are still calculating capacitance of the capacitor in the third question, the C part. But this time around, what has changed? The space between the two plates is now filled with a dielectric substance, which is mica. And the relative permittivity of mica is given to be 5. So it's required to use this formula for the C part. In the C part, we are calculating for C again. We are calculating for C. So say C is equals to E naught ERA over D. Now, E naught is a constant, which is 8.85 times 10 raised to the power minus 12. But this time, the relative permittivity, which is the ratio of permittivity of the material to that of a vacuum, is given to be 5 times 5 times our area still remains 0.01 over our distance has not been changed, which is 0.02. Please don't get it confused. The A part we use E arrow to be 1 because it is assumed no material was placed in between the plates. But in the C part, we are told mica is placed in between and the relative permittivity was 5. And that's why we have 5 here. So we go ahead to multiply and see what we get. 8.85 times 10 raised to the power minus 12 times 5 times 0.001 divided by 0.02, which will give us 2.2125 times 10 raised to the power minus 12. And the unit once again is farad.
There is a question here on the board for you to work it out. You don't do, you do not know. So that it's not as if you are just looking as the magic is going on. So there is a question for you to work it out. It says calculate